So we're moving to Chapter 16, FileIO. You probably brushed on FileIO in beginning Java. Now we're going to hit it again. There are different methods of FileIO. Text file data is one way of doing it. And then writing objects out as binary data so that they can be reread back in as binary data is another way of doing it. Now that's pretty cool because your programs look very elegant if you do that. You're just writing an object out with one call. And then when you're ready to read that object back in, it's just one more call. Boom, it's done. However, there's a drawback to that, which is that it's a Java specific. Sorry, there's some noise out there. It's very Java specific. So if you want to write something that's going to exchange data with another program, you probably don't want to do this. And the other problem is that if you ever go back and change your class so that objects have different data in them, then it's no longer compatible with data files that were already written with that mechanism. That said, we're still going to talk about it. So using files for input and output. So far, the input that we've done has come from the keyboard, and the output's been to the console window. Okay. So keyboard and console input is temporary, not permanent. You wouldn't want to have to type in, the entire United States Census every single time you wanted to run a report. You'd want to save it in a more permanent fashion so that you could load it and run multiple reports over it. Now for a data set that large, you'd use a database of some kind rather than a simple file. But what we want to do is create permanent I/O in the form of files. The file extension should suggest how the data is formatted. If it ends in .txt, you're setting up the expectation that you could open it with a text editor and look at it and change it. TXT text actually has some advantages because anybody else could write a program that would read that file. And that's very common in the Linux, Unix environment, is to provide input and output in the form of text so that you could chain your programs together and be sure that they could all communicate with each other. So the benefit of reading input from a file, you can use the data over and over again without having to re-enter the input. Once you've got your rainfall values for the year, you don't want to have to just keep typing that in each time you want it. Benefits of saving your output to a file. The output can be reviewed without having to rerun the program. Allows program chaining where the output of one program is used as the input for another. HTML file generator. Are we going to look at this example for very long? Probably not. But here's what they want to do. Read in this file and then produce this output based on it. And these are HTML tags. So what is it going to do? The first line of data becomes used as the title of the page and then as the header of the page. And then each time we read a sentence in, that becomes a paragraph tag, the /p tag. And then every opening tag needs a closing tag, so we keep track of all that. Well, actually, they're not doing that. That's pretty naughty. They're not closing their tags. If we were going to write this program, maybe we will, then we would want to make sure that all of our tags are closed because that's proper HTML. What you see here, HTML here, /HTML here. Oh, this is so badly formatted. This is terrible. There's no body tag here to match this closing one. If we do this, ours is going to be a lot better than that. But I'm going to skip their example. All right. I'm beginning to remember why I didn't like this chapter, which is that the examples are extraordinarily paltry. Two types of I/O that we're going to concentrate on. Writing text data out and reading text data in. To write text data out, you can create what's known as a PrintWriter. A PrintWriter lets you print to a file just as easily as you have been printing to the screen. Print line. There's also printf statements, I believe. So printing to the file is just as easy as it has been before. All you have to do is to create your PrintWriter object, open the correct file, and then you're good to go. Let's give that a shot. But we're going to have to put in all sorts of exception handling to get it to work. So in general, our syntax is going to be this. Our flow, skipping the exception handling, is we need PrintWriter with a file handle, a name for our file. Out file is good enough. And then we're going to say is equal to new PrintWriter, and then we need to open a file name. Once we have that, we can start going lickety-split. We can start doing outfile.println, hello. Then we can close our file, outfile.close. But what I like to do is to separate the creation of the file rather than just pass in a file name object. I like to have a file object hanging around. So what I do is this, file with a lowercase f, is equal to new file, and then I pass the file name in. And then when I create the new PrintWriter, I do it like that. Sometimes instead of out file, I might call it PW, for PrintWriter file or whatever. So let's give this syntax a shot. Go ahead and open up Java, make our new project. November 15. Remove the package definition. Move the class to its correct folder once that's done. Alright, I'm going to make liberal use of NetBeans' ability to fill in the imports here. But let's comment it. Create a PrintWriter to save our text output as a file. So file, capital F, file lowercase f, is equal to new file, and we're going to pass in a file name, output.txt. I may already have output.txt strewn all throughout this thing, so I'm going to call it something a little bit different. I'm just going to call it November15.txt. TXT is because it is going to be a text file that we can open up with Notepad, as we will see. Now we don't have a file class. Cannot find symbol. Add an import for java.io.file. I let NetBeans do that. If you like typing it in by hand, import java.io.file. Alright, now let's create a PrintWriter. PrintWriter, I'm just going to call it PW out. How about that instead of out file? Or even PW. Is equal to new PrintWriter, passing in that file object. And guess what? PrintWriter is a class. We need to add the import for it. Add import for java.io.PrintWriter. We're getting the idea that maybe we should have just imported java.io.star. Why don't we do that? Make things a little bit easier on ourselves. Maybe we have fewer imports we need to add. So import java.io.star. Let's see if that's good enough for the vast majority of this. And we're getting the error. Unreported exception, file not found. Must be declared or caught. Well, we'll handle that after a while. All right, we have our PrintWriter, pw.print. This is the first line of my file. pw.print \n. Do you really want to do it that way? No, you might like using println, pw.println. This is the second line. Let's try printf, pw.printf. And we even have %s \n end quote comma printf. Then we close the file. pw.close. You always want to close the file as soon as you can so that it's not left locked by your program in the operating system, so that if you had some background script that was copying these things into a backup folder, then it wouldn't skip that file because it was in use. Alrighty, we do have this problem here. Unreported exception, file not found. So here's what I'm going to do. And there's always more than one way to write this stuff, but I'm going to say file is equal to null, semicolon. I'm just going to leave that there to cut later. And then PrintWriter PW is equal to null. Leave that there for later. Then I'm going to move those two things. I'm going to make this say file equals new file, and PW is equal to new PW. And then I'm going to cut this one. The file is equal to new file. Sorry for all this little surgery there, but there we go. I just wished that I had created these objects beforehand. File is equal to new, PrintWriter PW is equal to null. That way I can put this stuff in a try block. Try this stuff. What are we trying? We're trying the creation of the file, which oddly enough never fails. It doesn't throw any exceptions, or at least it didn't demand that we handle them. Then we need to catch. What are we going to catch? We're going to find out what exception that the creation of the PrintWriter throws. So I'm going to go check the Java doc. If I'd been smart, I would have looked at the warning earlier. Show Java doc. It throws a file not found exception, or a security exception. File not found exception: if the given file object does not denote an existing writable regular file, and a new file of that name cannot be created, or if some other error occurs, you get file not found exception. Okay, so that's pretty vague. If some other error occurs, it'll tell you file not found even if the problem was not that the file wasn't found, but that it couldn't be created. You gave it an invalid, path, invalid drive letter. You put an illegal character in the file name. It's going to say file not found. So what we're probably going to do in that case is just say could not open file, could not create file. So catch file not found exception EX. And if that's the case, let's print an error message. Now what I really wish I'd done is put this variable right here into, that literal right there into its own variable. So I'm going to do that. I'm going to call it file name. String file name is equal to November15.txt, or whatever you feel like calling it. And then down here, when I create my file, I'm going to open a file name like that. New file, parentheses, file name. Why? So that I can print out error messages. System.out.printf error could not open %s \n end quote comma, and then our file name. Now, if we get to this point, it means that PrintWriter would be null. It means it failed to open, but we could enforce that. Or we could create another variable that said file opened OK. There's always more than one way of doing this. So I think what I'm going to do is I'm going to come up here and create a Boolean variable. Boolean file OK is equal to false. But if we get to this point, after the PW is equal to new PrintWriter, then we're going to set file OK is equal to true. And we're going to use that as a flag down here to determine whether we should issue our print statements or not. Hope that makes sense. So we're in main. We have these 4 setup things, our 4 variables created. We have our try block. Our try block consists of 3 statements. File is equal to new file. PW is equal to new PrintWriter. And if those 2 things succeed, then file OK is true. If they fail, then file OK is false. We know that for a fact because we already initialized it to false, so I don't feel compelled to reset it to false here. So let's put these print statements inside an if block. If file OK, then do this stuff. And I'm getting a weensy little error here, dereferencing possible null pointer. Well, that's not true. It will never be null. I guess we could do this if file OK and PW not equal to null. If we were going to do if PW not equal to null, we wouldn't even need this file OK variable. So, which do I feel like doing? Leave them both there. For simplicity's sake, I guess. I don't know, 6 of one, half a dozen of the other. I'm going to leave off the check for PW is equal to null.
It doesn't get rid of the error if you keep it.
Pardon me?
It gets rid of the error if you keep it.
Yeah. It makes the warning go away. I kind of like that. I think I'm going to go ahead and... No, yeah, you're back, huh? Oh, invert your F. Right, like I care. Okay. So with that in mind, I'm going to go ahead and leave it as is. Now this isn't going to produce any output on the screen. Why? Our printing is all going to the file, not to the screen. So why don't we add a couple of print statements here and there to show that this stuff worked? Inside our try block, maybe we could add a print statement saying that we opened the file. System.out.println or printf opened %s\n end quote, comma, file name. Then down here, after we close the file, let's print a message out, system.out.println file closed, or file now closed. Data written, file now closed, whatever, you know. All right, that's enough. That's an illustration of using the PrintWriter to write out text. And the example in the book showed it being combined with a text reader as well as a, something that wrote out. And so I prefer to start small. Let's see if it works. Hammer and broom. Run it. Run the project. Open November 15.txt. File not closed. Let's go find that file. So let's go remind myself of where our projects are stored. In my case, I think they're stored out in Documents, NetBeans Projects, November 15, and there it is, November 15.txt. If you don't have extensions enabled on your Windows browser, if you're using Windows, I strongly encourage you to do that. Go into folder options if you're on a version of Windows as old as this, or just find out where you set it. But that extensions convey very useful information. Or you look over here and it says text document. Anyways, I double click it and boom. Now that's not looking too hot. This is my first line of my file. This is my second line of my file. And we even have printf. And if I did, well, that's interesting. Didn't I write out a \n?
Yes.
So why are these two things combined on the same line? Maybe I should have used /r/n. If you edit it with another text editor, like TextPad, open with TextPad or something like that, it would look better. Notepad is just finicky about wanting both character turns and line feeds. And apparently PrintLine does display both character turns and line feeds, whereas print \n does not. If we are really curious about the contents of it, we can open it in a hex editor. So I'm going to go to hex, hexed.it, hexed.it. I'm going to do open file. I'm going to go and find that file. And you don't have to do this. We're just taking a look to see why that we got that little bit of discrepancy. Going into November 15, I'm opening my txt file and I see the ASCII output. This is the first line of my file, and all it wrote out was a 0A. When I printed that \n, that was a 0A. This is the second line, 0D, 0A. So if I wanted that to work in such a way that it could be opened by Notepad, I better not just do print \n, but I could just make that print line. That would work. Or I could do this, print \r\n, which is a 0D, that's a 0D, and that's a 0A. Now when I run it again, and I go and open it again, can't believe I closed the path again. Honestly, just using PrintLine to do it would have been the faster solution. But I open it again, and there we have all three separate files. Now, that convention goes back to DOS, before Windows 3.1, and Windows programs, early Windows programs written for Windows 3 and Windows 95 are expecting those character turn line feed pairs, whereas if you're using Unix, Linux, Mac, or whatever, it doesn't want character turns and line feeds. Maybe those programs will work. Anyways, if you ever open up a Notepad file and it's all on one line, it's because it was written out only with new lines without character turns, and any other text editor would work, but Notepad would not. I'm going to just make this print line and be done with it, okay? There. That's one way of writing to a file. Let's read from that file now. Well, but before we do that, now that we have our file open right up here, let's see what methods we have available to us. So file is equal to new file, file name. That's the line that I went to right under our try block. We're not probably going to keep any of this stuff, but file dot, and what is available to us? Could we read the file? Can we write to the file? Create a new file right there? Get the absolute path? That's kind of neat. Get the canonical path? Then you start wondering what the difference between a canonical path and an absolute path is. Well, let's print one of those out. Let's see if we can get that to work. So after file is equal to new file, system.out.println file colon end quote plus file dot get absolute path. And let's do the same thing with get canonical path. So I'm just going to copy that line of text, paste it, and change get absolute path to dot get canonical path. And there's even one more called just get path. Ooh, that's giving us a red underline. We may not be able to use it. Unreported exception, IO exception. If we do this, we're going to have to come down here and add another exception handler. I guess I'll do that. Anyways, I wanted to get that third path. So I pasted my line again, and I'm changing it to file dot get path. And sure enough, since we put this IO exception in here, we need to add a catcher for that. So down here underneath catch file not found exception, catch file IO exception EX, and that's all we're going to print. System.out.printf error IO exception on %s \n end quote comma file name parentheses semicolon. And it's a capital O, excuse me. FileIO with a cap. Really? Okay, I botched that. What did I do wrong? Don't cut this like I'm about to do to go and find the error. Java.io exception, not FileIO exception. So it's just IO exception. Sorry about that, guys. So it's not catch FileIO exception, it's just Java exception. And if that does give you an error about class not found, go and click on the error and let it go ahead and add the import. You know, you get addicted to clicking on that thing and letting it do its fix. But if it's not just adding an import, if it's asking to create the class, don't do that. Go and figure out what your mistake was. Because what I see people do is something like this. Don't type this. This is just an example. But down at the bottom, you know, dummy D is equal to new dummy, right? They thought that dummy was a valid class. And then they go, oh, error. Oh, well, that'll fix it. Create class. And if all the problem was that they had a typo, like this was IO exception with a little o, like that is equal to new I lowercase o exception, that's going to be a mistake. You don't want to create a class called IO exception. You want to fix it so that it actually works. Same with the scanner. If you had the case wrong, scanner, you know, but with a capital R, SC. And you go, oh, well, that's an error. And you come over here and you click create class. Well, it makes the error go away momentarily. But it doesn't fix anything. It brings, you know, your scanner's not going to work. You're not going to be able to call next line, next double, whatever. All right. Anyways, we got these three paths. That was just all out of curiosity, but let's run it and see. Okay, that's the path. Looks like the path. That's the results of get path, which is just a file name. One of these was canonical path, and one of these was absolute path.
I don't see a difference.
I don't see a difference there either. So if we wanted to go and Google the difference between canonical and absolute paths, we could do that.
So let's do it.
So, what is the difference between canonical path and absolute path in Java file? Stack Overflow is our savior. Consider these file names. C:\temp file.txt, it's a path, an absolute path, and a canonical path. /file, it's a path, but it's not absolute or canonical. Blah, 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 blah is a path and an absolute path, but it's not a canonical path. Okay, so the canonical path is the most true path. An absolute path could have, why would you do that? That is absolutely insane. Okay, anyways, I would use canonical path. It looks like the complete path without any weirdness. Converting from a path to a canonical path makes it absolute. It tacks on the current working directory. The canonical path purifies the path, removing and resolving any wildcard characters or any ... dots. What does that mean? Nobody uses DOS anymore, but if you want to go up a level in a directory in the command prompt, cd ... takes us up a level. Similarly, if we wanted to, we could put that stuff in our file name. Instead of just file name is equal to november.txt, we could do dot dot backslash backslash, and then let's give that a whirl.
Feel free to build it.
Still the same results. Nope, not the same results. That worked, right? Our absolute path contains that dot dot, and then our canonical path resolved it so that it's actually in the correct directory, which is one up from where it was before. So canonical path is your friend. That's the correct path. So I'm going to get rid of these other two. I'm just going to comment those out. And let's make that message, it says file, colon, a little bit clearer. Trying to open file, like that. Now, do you need all this stuff in order to do a PrintWriter? Obviously not. You don't need to be printing the path. Another thing that people do is that they put their print writing statements, their print lines, right here after they create the file, so that the entire block of code is just enclosed in one try block. That's okay too. Let's do that. Let's make a second example. Come down here. Let's reset our file name. File name is equal to other.txt. File is equal to new file based on the file name. PW is equal to new PrintWriter. We should have set these things to null, or before we did this, or created new variable names. Why? Nah, we're not going to bother though, because we're going to put everything in the same case. PW dot print ln. Here is our tasty data. And then just close it. PW dot close. Now let's put this all in a try block, but let's go and look at the error first, just to remind ourselves. File not found exception. Okay. So try all of that stuff. And then catch our exception. File not found exception ex. Let's print out an error message. System.out.println could not open could not open space end quote plus file name. It's actually a lot cleaner and a lot shorter. Feel like doing it that way? That's totally cool. Obviously, it's a lot, like I said, cleaner and shorter. Why would you want to break it up like this? Because you can make this code loop until they do give you a good file name and you actually successfully have the file open. This is just a one shot. You try to open the file, you try to print to it. If it doesn't work, too bad, you're done. This first method gives you the chance of looping until we actually do get the file open. One of the things we're going to try next is to try to open an invalid file, something with a bad path, bad drive letter. So run it. The second one didn't even print anything, right? I forgot to have us put any print line statements in here at all. So why don't we do that? After the PW close, system.out.println, let's print the file name plus a space closed. That way we see something. other.txt closed. Okay, great. For your assignments, you feel like doing it like that? That's totally cool. Let's fill in a bad file name. Does this machine here have a G drive? No, it does not. So I'm going to go up here and make it G:\\other.txt. Could not open G.other.txt. What's the reason? Because that path does not exist. All right, let's write. I'm going to undo that, and I'm going to make this print out some more things other than just here's our tasty data. So we have something to play with when we read the data back in. pw.println. This is another line of text. pw.println. This is a third line of text. Why are we doing that? Because the next thing we're going to do is to write some code that will read that stuff in. So if we look at their code in the PowerPoint, they show how to make a text file reader using the scanner. What's cool about that? Because once we create our scanner, it's as easy to use as our scanner has always been. We can call .next, next double, next line, whatever, to pull the data out of the file, just as if we were pulling it from the keyboard. Now they show something squirrely here using paths.get. I'm going to see if I can avoid that. I'm just going to try creating another file. Same mechanism we did up here. So file name is equal to which of these files?
In a try block again.
Yeah, eventually it's going to wind up being in a try block again. So file name is equal to other.txt. File in file is equal to null scanner sc or sc file or sc in. How about sn file? It's equal to null. We don't have an input for the scanner, so I'm going to add the import, the java.util.scanner import. Scroll up and do that if you like doing it by hand. All right, try. But I'm not going to put it in there first because I just want to see what exceptions it can be through. Well, I can always just check the Java docs. So try. In file is equal to new file based on that file name. Scanner is equal to new scanner based on that in file. And it says, can I find symbol? Variable scanner? Oh, unreported exception. File not found exception, yet again. Alrighty.
Your scanner should be SN file.
Yeah, you're right. That's wrong. It's not scanner is equal to, it's SN file. It's still complaining about our exception, file not found. So we can handle that. Catch parentheses, file not found, exception. Same business. System.out.println. Could not open plus file name plus space for reading. We should have made the other one could not open file name for writing. And I forgot to make a variable, so catch file not found, exception space EX. All right, I have my little thing that I can play with. It's a scanner, just like any other scanner. So, while SC dot, no, it's not SC anymore. I should have just called it SC. While SIN file dot has next line, make sure we have a line of data. Let's read that data in. String text is equal to SIN file dot next line. And let's print it out. System.out.println. We just read colon space end quote plus text. Once we get to this point, we don't have any more data in it, so we can close the file. Send file dot close. And again, this is the type of stuff where you could argue that you ought to break it up into two things, so that if they give you a bad file name, you keep asking for the file over and over and over until they give you a good file name, and then you could go and read and process it. I'm going to condense this a little bit, see if we can try to get the whole thing on one page. Obviously we can't. The file name is equal to that. File in file is equal to that. Scanner SN file is equal to that. Why am I setting everything to null? Well, I'm even getting warnings over here saying that the assigned value is never used, but it's like, too bad, NetBeans, just be quiet about that. The reason I like it is so that if I was going to break it into two chunks of code later on, I could do if SN file not equal to null, then do this kind of stuff. Then we have our try block. It's got that stuff in it. We create a new file, create our new scanner, while SN file dot has next line. Read that line in, print that line out, close the file, and there's our catch clause. Catch file not found exception. Print an error message. Let's see if it works. Alright, so out of that file, here's our tasty data. This is another line of text. This is a third line of text. Very good. It did in fact work. I think that's good enough. I think I'm not going to write it so that, you know, it loops on it. There are other ways of accomplishing it than that anyways. Was there anything else in the file class that was fun besides get canonical path? I don't know. Let's find out. I'm going to go back to that line, end file is equal to new, and I'm going to type end file dot. Can we read from the file? On some platforms, it may be possible to start the Java virtual machine with special privileges that make it read files that are marked as unreadable. Okay, that's pretty weird. Is it a file or is it a directory? Do you want to make a directory? You can make a directory right then and there. That's kind of neat. We'll work with that a little bit in the upcoming weeks. Doing a system I/O where we read a directory, we pull out all the files in it, we find the ones that have the extension JPEG or something like that, and then we launch a viewer to show the JPEG, that kind of stuff. Anyways, I'm going to get rid of that end file dot, and I'm going to consider this program done. I'm going to go and add some comments up at the top. Demonstrates using PrintWriter to create text files and Scanner to read text files. This has two examples of using PrintWriter. The second example, cleaner then the first, because all of the code is in one try block. All right. I think we are done for the day. Any questions?
I just need to go read up on files. I vaguely remember doing this in Python.
Yeah.
Years ago.
All right.